In the previous chapter, we talked about our whitewater source and our whitewater fields, and we saved them both out. Now let's talk about on how we can set up a DOP network to simulate our whitewater points. So I'm just going to drop down an empty DOP net here, and I'm going to drop down a bunch of nodes here. So whitewater object, whitewater solver, a merge node, and then I'll connect all of these together. So the first input of my whitewater solver connects to the output of my whitewater object, merge into my solver and output. And before we talk about anything, what I want to do is I want to go to the limits tab, and I want to make sure that my limit size and my limit center is matching the size and the center on my ocean source node. And it's set to 0 at the minute because we're in manual mode, so that's why you don't see any values. So I'm just going to say copy parameter and paste relative references, and then the exact same thing with the center, copy parameter and paste relative references. Now this is great because once I change this value on my ocean source node, which is here, which is connected to the bounds. So when I change that value on my bounds, everything would automatically get changed, including my flip container and my whitewater container. Right. And what I also want the collisions of my cliff to my whitewater. So instead of setting that up again, we already have a static object set here. So I'm just going to Control C that and then go down to the whitewater points and Control V that here and connect that to the merge. I'll make sure that the static object is my first input. Okay. Now in the whitewater solver, there is under the emissions tab, there is a string called emission source. And what I'm going to do is I'm going to call in the out whitewater source in there. All right. So browse object effects and out whitewater source. Right, so what I want to do before we talk about anything else, before we talk about all the whitewater scale and the voxel size, I want to do a flipbook. So I'm going to put that to auto update, and I'm going to do a 150 frame flipbook. So now we can see that our points are being emitted here, but their behavior is not what we were expecting. The points are getting emitted and they are frozen in time. There is no force applied to it. They don't follow our flip simulation at all. And this is where the surface and the well field that we saved in the previous chapter come in handy. So these out whitewater fields. So if I middle click on this, you can see that we have a surface and a well field. So we need to find a way to call these two fields into our DOP net. So when we emit our whitewater points from the source that we mentioned here, they also follow the well and the surface field of our main flip sim. And it's easy. The volume source, that's where we have to call in our whitewater fields. Done. And before I do another flipbook, I would like to talk a bit about a couple of options. And in the forces tab, the base advection strength is set to 5 by default. Now this is the strength. The more this number, the more strongly your whitewater would follow your flip simulation. So for this one, I really want the whitewater to stick to my flip sim, so I'm going to put that to 12.5. And under the limits tab, we don't really need to talk about anything, but under the emissions tab, under the advanced tab, we have aging rates for bubble, foam, and spray. So what I'm going to do with this is I'm going to put the aging rate of the bubbles to 100 and aging rate of spray to 200. Again, these values are not set in stone. This is very project dependent and obviously very subjective. How your whitewater should look is entirely dependent on you and obviously the kind of shot that you're doing. Now I'm increasing the aging rates of the bubble and spray here because I don't want the bubbles and spray in my whitewater sim to linger around. So the more the number on these aging rates, the faster they would die. And I'm going to increase the overall lifespan of the points as well to 6 from 5, and the maximum initial speed from 10 to 14. So the whitewater speed would not be over 14, initial speed that is, so it wouldn't be over 14. Right, and last but not least, the velocity multiplier, I'm going to put that to 1.3. Now by default, most of the settings, most of your shots or most of your simulation would work on the default setting of 1. But for this project, I wanted that oomph in my whitewater when they emit, when the spaceship collides. I wanted the whitewater to go a little bit higher than my actual flip sim, and that's why I put the number 1.3. So a multiplier applied to the source point's velocity before its whitewater particles inherit it. So that's going to be 1.3. Right, and what's the other thing we can do? We can do one more thing. We can do dop import fields and make sure that our whitewater is being called in to our SOP level. So dop network, and then dop network, and then whitewater object. All right, and then we can do particles because we just need particles. We don't really need the surface and the well field or any sort of other fields for this. We just need particles. So we're going to do that with the geometry here. And one other thing that we can do here is, because whitewater creates a lot of groups and attributes and stuff, so we don't really want them, but we'll talk about that in the future video. But for now, what I'm going to do is I'm going to put a group delete SOP here, and then that would delete any group that whitewater may create. And before I flipbook this again, what we're going to do is we're going to use this attribute VOB for the visualizing our points. So remember in the previous chapters when we were setting up our flip sim, post sim, we did an attribute VOB based on the length of the velocity, and it's exactly the same thing. It's based on the length of the velocity, except the ramp is a little bit different and the range is set to 0 to 15. So I'm going to connect that there, and then I'm going to do another flipbook. So let's fire up another flipbook and see how our whitewater particles are looking now. So now you can see that our whitewater simulation is following our flip sim, and that has to do with us adding the surface and the well field to the simulation. Now we got some really nice movements here, but we got to change a lot of things in here as well to make it look a bit better. And to start with, let's talk about the whitewater scale and the voxel size. Now whitewater scale is essentially the resolution of our whitewater. The lower this number, the more whitewater it would generate. And the voxel size is also a very important parameter, because voxel size is controlling all the density control and the erosion and stuff. So voxel size is for the density volume. The volume is used for emission limiting, foam erosion, which we will talk about in a future video, as well as the repellent seeding, which is also very important, which we will talk about it. When density threshold is enabled, voxel size should be at least twice as large as whitewater scale. And all these density control, erosion and repellents, it's under the foam tab here. So I know it says that it should be at least twice as large as the whitewater scale, but in my testings, I found that to be a little bit of an overkill. But obviously this is very shot dependent, and this setting here should be taken with a grain of salt, because in your scene, whatever you're doing, you might need a little bit less or lower voxel scale. So I'm going to multiply that by 4. So we're going to talk about what resolution we're going to be going for our whitewater scale in a future video as well. Right, now let's talk about the density control, erosion and the repellents in our whitewater sim.